Hey guys, how are you doing? All of us have been following the recent news about Iran-Israel conflict. The sky over West Asia lit up for 12 days. Iran and Israel locked in on unprecedented aerial standoff, and USA also entered the scene on 22nd June 2025. Trump said if Iran continued its uranium enrichment program, America will bomb again. And Iran's supreme leader Ayatollah Ali Khamenei said if America bomb again, it should be prepared to face severe punishment. Iran is now bent on pursuing its nuclear armament programs. But what is uranium enrichment? Why does it terrify world powers, and how does this scientific process based on atomic mass and centrifuge hold the key for nuclear energy or annihilation? In this video, we decode the physics behind uranium enrichment, not just for headlines, but because UPSC has repeatedly touched this topic in GS Paper 3 on science and technology and energy security part. Let's break down this nuclear puzzle scientifically. First of all, we'll discuss about uranium, natural uranium. Alright, so here we go. Just a minute. So uranium enrichment is basically converting natural uranium. Let me use my pen paper. So it is basically what it is. It is converting natural uranium which is primarily uranium-238. You have done it basic science in your 9th class. Again, most of the topics are coming from basic science, right? Into highly enriched uranium, right? Highly enriched uranium, which is actually uranium-235. Let me remind you guys again the very basic. Okay, suppose there is an element like for that matter uranium, and it is written like this. This number denotes atomic number. From basic science it is atomic number, and this number which is above upstairs, it denotes basically mass number, right? From the basic science, mass number. If I were to write, from basic science, if Z is same, it is called isotopes. For example, we are talking of uranium-235. Uranium-235, scientifically, it is like this, 92. And uranium-92, it is written as 238. So, they are the isotopes. These are two isotopes of uranium. It simply means their proton numbers are same, number of protons are same. And their electrons, number of electrons are also same. Right, so chemically uranium-238 and uranium-235 are same. That's the basic essential idea. But this uranium-238, it is not fissile, right? Uranium, natural uranium, and natural uranium is this. This is the basic. Natural uranium consists of 99.2%, or roughly, otherwise this portion signifies this 99 point approximately 3% is uranium-238, and this is small 0.7% or 0.72%, it is basically uranium-235. So nature has uranium in this kind of mixture, which is uranium-238 and uranium-235. But why the world is talking about uranium-235? Because uranium-238 is non-fissile material. What is the meaning of non-fissile? Simply it means it can't sustain it can't sustain nuclear reactions or chain nuclear reaction, or otherwise you can say nuclear chain reaction, right? Whereas it is found that, and we will talk a bit more physics about uranium-235 and 238. Uranium-235 is basically fissile. It is fissile material. It is fissile material. What does this mean? It simply means, what it does basically, it can sustain nuclear chain reaction. Uranium-235 can sustain nuclear chain reaction, right? Nuclear chain reaction. You will understand it shortly. Chain reaction. And therefore it is of our use. That's what is the basic idea. So enrichment is what? Enrichment is essentially what? Simply it means uranium-238 को convert करना है किसमें? uranium-235 में. What we are going to do? We are going to increase the concentration of uranium-235. And from where? From 0.7% to maybe 5%, maybe up to 20%. I will talk a bit later, and maybe up to 90% and plus, and you might, now guess, the more enrichment is there, the, you are in the journey towards nuclear weaponry, right? Nuclear weapons, right? For example, 20% maybe you can understand nuclear reactor purpose, for generating electricity. So if you want to look at this, let me tell you this periodic table which you have done in your 10th class. So this is uranium 92, let me tell you, these are 91, 92, these are lanthanide and actinide series, and lanthanides are also very, very important, they are, basically rare earth metals whose video I'm going to, make sooner. And uranium, this is uranium, this is actinide, and by the way, thorium, actinium, thorium, proactinium, uranium, neptunium, for that matter, plutonium, all of these elements are radioactive in nature, and on radioactivity we have made one, basic video, right? All right. So if we were to talk a bit more, so two types of enrichment is possible. This is called low enrichment, LEU, low enriched uranium. So low enriched uranium, it simply means uranium-235, you have increased the concentration up to what? 0.7% to, you can write here, earlier it was 0.7% to less than 20%, around 20%, and this is called low enriched uranium, right? Okay, and this can be used in nuclear reactors. What it does actually in nuclear reactor, chain reaction is sustained and then heat is generated, and what we do actually, this heat is used to make steam, and this steam is used to rotate, turbines, and these turbines in turns with the electromagnetic induction effects, they produce actually electricity, and this is cleanest way of producing electricity, and they have a lot of power, but we will talk about it, right? So they have very good potential of generating electricity, right? Uranium, if it is more than 20%, more than 20%, then it is called highly enriched uranium, right? Highly enriched uranium, HEU, if uranium-235 is basically greater than 20% up to 90%, up to 90% or even more than 90% basically, right? This can be used to make, this kind of enriched uranium can be used to make research reactors, and not only research reactor but basically nuclear weapons, okay? And these nuclear weapons, for that matter, a bomb, you might have watched movie like Oppenheimer, तो वहां पर आपको पता चलेगा a bomb कैसे बनता है ना, and this is based on the concept of splitting, heavy element into, smaller ones, right? So what is the physics behind? Essentially in this video, our goal is to understand the physics behind uranium enrichment. This physics is very simple actually. Let me tell you why you can't use chemical methods. Uranium-235 and uranium-238. Again, if you were to write it in the language of chemistry, then you write 92-235, and uranium-92-238. For that matter, let me tell you, number of neutrons are different actually, right? This number denotes number of protons. It also signifies the place in a periodic table, right? So they are chemically same. Essentially, these both are chemically same. They are not chemically different, right? Okay. So if they are chemically same, you cannot employ chemical methods. You can't employ chemical method to separate them. Chemical methods to separate them, right? You can't do that. Separate. So if you were to talk about number of neutrons, so number of neutrons are given by this difference A minus Z, and it should be around what? It exactly 143, right? And it is 146. So 238, 235, and then it is 146 number of neutrons. So number of neutrons in this, suppose you were to write electrons 92, number of protons 92, number of neutrons in uranium-235 is 143, right? Electrons and an atom cannot hold too many protons or too many neutrons, but at least an atom cannot hold too many protons, because there will be electrical repulsion, it will lose stability, right? So but it has 92 because natural elements are up to only 92, up to uranium only, others are made, in laboratory, they are artificial elements. Number of protons are again 92, number of neutrons are 146. So you cannot employ what you can't do actually, you can't deploy any chemical methods because they are chemically same and they are terminology is isotopes, they are isotopes of each other. Okay, so what physics they are going to use, to separate them? A physics is used basically, it is based on the principle of centrifugation, the principle of centrifugal force or centrifugation. And if you want to understand the basic concept of centrifugation, it is based on, for example, circular motion. If you are driving on a turn on a circular road, right? So suppose there is a path, this circular path. If a particle is traveling, let me tell you, suppose a particle is there, which is, moving around this circle. So this is basic physics, this is radius r. Suppose a particle is basically, this particle, suppose a car is moving along this path with some velocity v, then if an observer, in the language of science, if I am sitting here, I am standing here, and if I want to look at this guy, I will look at this person, it is experiencing a force towards the center. This force is called centripetal force, this is the basic idea. But suppose this person is sitting in the car and if he wants to, he will find that somebody is pushing him away, like this. If I were to sit here and if I want to see my, force acting on me, then I will find, a force acting, on me, which is sending me outwards. And this force is also equal to mv square by r, and this Fc is also equal to mv square by r. Okay, centripetal force, if I am looking from outside and if I am looking from the same frame, then I will find, if you are turning on a sharp turn, you will find that somebody is pushing you, outward, and that force is called basically centrifugal force. This force is called centrifugal force, and this is the centrifugal force, right? And you could understand this, it depends upon the mass also. And if you have understood this basic science, you can easily guess now what I am going to talk now, right? So if you have understood this science, so let me tell you, okay, this I have this, already. Okay, so if you want to see this, this slide is with me, right? This force is basically, it is like, you have done it separating, substances based on their density basically. So centrifugation is a method of separating substances or mixtures basically. Substances or mixture based on density difference. Based on density difference, right? And density has to do with mass, right? So what we do, we spin something, spin them in a centrifuge, which is rotating, is called basically centrifuge. Like this, this is called centrifuge. What we do, we spin them in a centrifuge, denser components move, those which have higher masses, right? So the idea is what? Denser component will move towards outer edge and slowly, and they will move slowly, right? Okay, so centrifugal force is acting outside like this, right? And heavy particles, denser particle, technically speaking, denser particles are going to move slower and towards outer edge, and these particles which are lighter particles, they are comparatively lighter, they will move towards the center. That is the basic idea. Where do we use it? We use it for this centrifugation, for example, separating cream from milk, this is where you use it, right? Where do you use it? For example, blood test. In blood test, for example, you have plasma, then you have blood cells like RBC, WBC, platelets. They have different density, and therefore you can separate, for example, complete blood count, CBC, this test is based on centrifugation, right? Then you have, DNA. We employ this method in DNA protein separations, right? DNA protein separation, separating blood cells, as I have talked to you, right? You also use it in washing machine for that matter, you know, in our day-to-day life science washing machine. This is the idea. Exactly same thing is done for uranium enrichment, and let me tell you, in this enrichment method it is called gas centrifuge method. This method is called basically gas centrifuge method. Gas centrifuge method, right? What we do exactly, how uranium first converted into this uranium, which one? Natural uranium. And you must remember now, this natural uranium has 99 point approximately 3% uranium 238, right? And 0.7% it has uranium 235. So what is done actually? Natural uranium, it is converted into gas. Natural uranium is converted into gas, and this gas is called UF6. F is fluorine, if you remember, right? So it is 6 atoms of uranium, 6 atoms of fluorine. It is called uranium hexafluoride, है ना? I hope यहाँ तक आपको समझ में आ गया होगा. So this natural uranium is converted into gas with the application of temperature. Now, simple physics. This uranium hexafluoride gas, UFC gas is spun, you know, it is spun at high speed into a rotor, you know, this rotor. So what is happening? This uranium, like you can say, okay. So you must have understood what is the idea. There should be this rotor, in this rotor, which is spinning at a very high speed. Uranium UF6 is basically fed into this rotor, and this particle, these are uranium 235. Uranium 235 are comparatively lighter particles, and outer edge you will get uranium 238. I hope you have understood. This is how they stay slightly inwards, right? So uranium 235. So you can write down uranium 235 stays closer to center, whereas these particles are basically at outer edge with speed a bit slower, right? A bit slower. Now it is not single stage process, basically it is a multi-stage process. Remember, this is done again and again, multi-stage process, and technically it is also called cascade, right? It is called cascades. This is how it is done, cascades, right? And gradually, slowly, a bit, one by one, slowly, concentration of uranium 235 is increased, and this process is called uranium 235 enrichment, from 0.7% to 1%, 2%, 3%, 5%, then 20% and above 20%. This is the idea. And once you have this uranium 235, then you can, what it does actually, why it is fissile material. Let me now quickly wind up this video with this last, heading. And in this last head, what we are going to talk about, fissile means simply, it is this material, this uranium 235, this is going to absorb thermal neutron. What it is going to do? It is going to absorb thermal neutron, right? Slow moving thermal neutron, basically slow moving neutron, and this slow moving neutron will convert this into uranium 236. If you remember, this number 235 is basically mass number, and 236 means one more neutron is there. Number of neutron now it is 144, and here number of neutrons were only 143 extra neutron. And what happens now? This is unstable, this uranium 236 is unstable nucleus, right? And this is splitted into chromium and barium, right? And apart from this, it also releases these 3 neutrons, and these 3 neutrons will do what actually they will again, what they are going to do, let me tell you. Okay, I can now okay, I will make it another slide for you. So okay, for that matter, so what is going to happen? This is the basic idea, and we will make another video on this whole thing. Okay, so let me tell you this, right? Again, these neutrons, they are going to react with uranium 235. This is also going to react, with this nuclear reaction will take place with another 3 neutrons, right? 3 neutron, 3 uranium nucleus, 92, 235. Okay, again they are going to split into 3 neutrons, है ना? I hope आपको समझ में आ रहा होगा. फिर यहाँ से भी इस तरह से 3 न्यूट्रॉन, यहाँ से भी 3 न्यूट्रॉन और निकलेंगे, and this kind of reaction is called basically chain reaction, and this chain reaction is important to sustain so that you could harness energy. But if it is uncontrolled, then it is going to have explosion, right? So graphites are used, graphites rods are used, even heavy water D2O is used. We are going to talk about nuclear reactor in another video, and they are basically used for coolant and moderator. For example, like heavy water nuclear reactors, in those reactors D2O, heavy water, basically it is used as coolant also, right? And once heat is generated, lots of heat is generated, and this heat is used to make steam, and this steam is going to make turbine. They will rotate turbines, and these turbines are going to produce electricity. That's the basic idea, But you can ask me a very basic physics. What is the physics behind? How do you get energy? Einstein's famous equation. This is called Einstein's famous equation, and which is mass and energy are equivalent. So this energy comes from mass defect. Something is called mass defect delta m c square. What is c? C is called the speed of light. Or simply you have, you must have heard E equal to mc square, but it is actually delta m. What is delta m? The uranium 236 has greater mass. So uranium 236 has greater mass than these components, all of these added together, right? So mass of uranium, total mass of fragment, total mass of fragment. Okay, this is greater than, this sign is for greater than, right? This is greater than. So mass of uranium 236 is greater than. So it means there is some kind of defect. Where does this mass goes? And this defect, this mass difference, basically delta m is what? Mass difference. This mass difference is converted into energy by the equations, Einstein's famous equation E equal to mc square. I hope you have understood, and around, each fission release around 200 MeV energies, right? So we should wind up this video today here, right? So we'll get back to other videos. Remember one thing, I want to just make one line: enrichment greater than 5% is, or otherwise if you want me to write it, I can write it somewhere here. Okay, I can make the final comment. Enrichment, remember this thing for your UPSC, enrichment greater than 5% is red flag internationally. It is red flag internationally, right? So that is most important line, I hope this video is useful for you. So if you like this video, don't forget to hit like button, don't forget to hit share button, and don't forget to subscribe our channel. Thank you so very much. See you guys until next time. Till then, goodbye. Thank you.